Hey, we have here another integral on the board. I have the integral of arcsin x squared dx. Okay, now you may recall if you had the integral just of arcsin x without the exponent, well, the way we do that is integration by parts. And it seems like the same method went work pretty well where we just use integration by parts on this. So let's see how this works. I'm gonna use the DI method or tabular integration, of course, because I usually prefer that. And by multiplying in a 1 here, I can integrate the 1 and we can just differentiate the whole expression arcsin x squared. And so let's get the derivative here. So we'll just use the power rule on this. We're going to get 2 arcsin x, and then chain rule derivative of arcsin x is going to be 1 over square root of 1 minus x squared. And then over here, just looking at our 1, the integral of 1 is just going to be x. So we have part of the solution right here on the diagonal, so that's a good start. So we'll have x arcsin x squared, and then this whole piece here is going to be an integral. So we'll write this, I'll bring the minus 2 out front, and we'll have the integral of x arcsin x over the 1 minus x squared dx. And then from here, this actually doesn't look too bad, just noticing that the derivative of arcsin that we found before is just 1 over square root of 1 minus x squared. So this looks like it's in good shape for a u substitution. So for my u, I'm going to call my u equal to arcsin of x. And I'll just take the derivative, which is going to be 1 over square root of 1 minus x squared dx. Notice we have that right there. Now I can take this and find my value for x. So just using the property of the inverse, x is going to be equal to sine of u. And then I think what I'm going to do is just draw a triangle, because I want to get a value for cosine of u, because I know I'm going to need it later. If sine u equals x, we can write this as x over 1. So our angle is going to be u. So notice sine of u is opposite over hypotenuse, so x over 1 is going to give us our x. And then if we use the Pythagorean theorem to find our third side, we get this is going to be 1 minus x squared. So if we want to get a value for cosine of u, that's just going to be adjacent over hypotenuse. That's just going to be square root of 1 minus x squared over 1. Okay, so I think we have everything we need over here to the right. So I'm going to make my substitution. We'll keep our minus 2 out front. So starting with our x value, x is just sine of u, so we'll write that in. And then arcsine of x is going to be just u. Now our 1 over 1 minus x squared times dx, that's just our du value, so I'll just put that on the end. And that gives us just one other integral to deal with, this u sine of u, but for that, I'm going to just use integration by parts again. So we'll just do a quick di table for this one, but this is going to be pretty quick. So we're just going to have, I'm going to differentiate u and integrate sine of u. That's just because the u is going to differentiate nicely. So this is going to, derivative of u is going to be 1, derivative of 1 is going to be just 0. And then integrating sine, we're going to have minus cosine u, and integrating again, we're going to have minus sine u. So we're going to have our answer here on the diagonals. So let's see. So this first part's going to be minus cosine u, but I'm going to distribute in the minus 2 here. So I'm going to write this as plus 2u cos u. And then here, minus times minus is a plus sine u, but again, we'll have a minus 2 in front. So we'll have minus 2 sine u. And now we just got to get everything back into x, but we have all our values over here, so this isn't going to be too bad. So we're going to just have for our 2u, we're going to have u as arcsine of x, so I'll write that in. And then we got our cosine of u value, square root of 1 minus x squared, minus 2, and then sine u is just x. We're going to have minus 2x plus c, and that's it. Okay, so it wasn't too bad. We just had to do integration by parts 2 times. So we'll stop it there. Thanks everyone for watching today. Have a great day.